All right, we have an application for our dot product here. Theorem 2.4 with the proof on page 179 in your book is U dot V equals the magnitude of U multiplied by the magnitude of V multiplied by the cosine of whatever the angle that separates them is. And a general rewriting of that for ease, we set everything equal to cosine, so a little bit of algebra will give us this formula below. We're going to use that formula to answer a couple of these questions. So I've got problem number 131 down below, and we're given two vectors. We've given an A and a B vector. And we're looking for the measure of the angle theta between A and B. And we have to express it in radians, rounded to 2 decimal places if it's not possible to express it exactly. And then we have to determine if it's acute. So these over here determine whether or not something is acute or obtuse, or neither, in fact. All right, so in radians, as long as you're less than pi by 2, you're going to have an acute angle. So, so theta less than pi by 2 will give you something in the first quadrant, and thus acute. And so we've also got this down here where if the actual cosine itself is between 0 and 1, we'll have an acute angle. We're gonna try to solve for theta specifically, so this other thing down here isn't too big of a deal. For obtuse, something that will be in the between 90, 180 degrees, that sort of thing, we would be in the area of the quadrant 2. Also, if you have two vectors that are moving in opposite directions or moving in the same direction, you will have a 180-degree value for theta, and that would be these two here. So figure C, they're heading in opposite directions. Figure D, they're heading in the same direction. All right. And finally, what is known as orthogonal is if you get a perpendicular angle for them. And orthogonal occurs if and only if U dot V equals 0. So if that's the case, you're going to get a perpendicular angle, and they will be orthogonal. So let's try to work on this problem here. So we're given, let me scroll down a little bit. We're given vector A is 3 and -1. Vector B is -4 and 0. So we're going to use this formula here to find cosine of theta and thus theta. So cosine of theta equals A dot B over the magnitude of A times the magnitude of B. Well, A dot B is going to be just the dot product of these two, which is 3 times -4. Those are the first parts of each of them. And the second parts are -1 and 0. The magnitude of A is the square root of each of those squared, so 3 squared plus -1 squared. That's the magnitude of A. We're going to multiply that by magnitude of B, which is -4 squared plus 0 squared. And that gives us -12 over, looks like square root of 10, and square root of 16, which is just 4. So that gives us -3 over root 10. That is what cosine of theta is, which means that theta will be the arc cosine of -3 and root 10. So we can determine what that is. They want it in radians, so let's turn our calculator on and check the mode. I do have it in radians. So I want the second function in cosine to give us the inverse cosine. Use the dash, not the minus key. -3 divided by 10 to the 1/2 power is root 10. It's 10 caret 0.5. And this should give us what our theta is in radians. All right, so 2.82 rounded to 2 decimal places. So theta is 2.82. So the second part, is this acute? So if our theta is 2.82 radians, that is going to certainly be bigger than pi by 2, which is 1.5-ish, something like that. So this is not acute.